All right, let's just jump right in. The world of chemistry, it's not just a bunch of boring formulas in a textbook, right? It's actually filled with these amazing characters, each with its own totally unique personality. And the wildest part? You're bumping into them every single day. So today, we're going to meet three of the biggest players on this stage: acids, bases, and salts. I mean, have you ever really stopped to think about it? What is it that makes a lemon so sour it makes you pucker up? And on the flip side, why is a bar of soap so slippery and kind of bitter? Not that you should be tasting soap, please don't. Well, the answer to both of those questions, it comes down to these distinct chemical personalities we're about to meet. And I'm not kidding, these chemical personalities are everywhere. We're talking about the vinegar in your salad dressing, the citric acid in your orange juice, the heavy-duty stuff in drain cleaner, even the antacids you might take for heartburn. They are the invisible forces behind so many things we do every day. Okay, first up in our story, let's meet character number 1, the acid. The name itself actually comes from the Latin word for sour, and believe me, that is its defining feature. Think sharp, tangy, powerful. So what's the science behind the sour personality? Well, one of the first big ideas about it goes like this. When you dissolve an acid in water, it lets go of this very specific particle. It's called a hydronium ion. And you can think of this little guy as the source of all of an acid's classic traits. A more modern way to think about it, and maybe an easier way, is that acids are proton donors. Now, a proton is just a tiny hydrogen ion, and acids are super generous with them. Their whole chemical reason for being is to give one away. They're the givers in our story. But here's the thing. Not all acids are equally generous. You've got your strong acids, like hydrochloric acid. They are all in. The second they touch water, bam, they donate all their protons. Then you've got weak acids, like the acetic acid in your vinegar. They're a bit more reserved, They only give away some of their protons, and they hang on to the rest. And we can actually measure this proton-giving strength. We use something called the pH scale. Anything with a pH from 0 all the way up to just below 7 is considered an acid. And here's the crucial part. The lower the number, the stronger and more powerful that acid's personality is. So how do we actually spot an acid out in the wild? Well, we use something called an indicator. The most famous one is probably litmus paper. If you dip it into an acid, it turns this really distinct red or pink color. It's like a little chemical alarm screaming, "Hey, acid's here." All right, every great story needs an opposite, right? A rival character. So let's meet the base. If acids are all sour and sharp, bases are their complete opposite. We're talking bitter and slippery. Now, the most common type of base is called an alkali. And just like acids release those hydronium ions in water, alkalis release their own signature particle, the hydroxyl ion. This is the little guy that's responsible for that classic bitter taste and slippery feel. And this gets us to their perfectly opposite nature. Remember how acids are proton donors? Well, bases are proton acceptors. They are the takers in our chemical drama. Their whole purpose is to find and grab those protons that acids are so desperate to give away. Okay, so here's a key little distinction you gotta know. All alkalis are bases, but not all bases are alkalis. What does that mean? Well, alkali is just a fancy name for a base that can dissolve in water. So think of base as the big family name, and alkali is just the family members who like to go for a swim. And just like acids, bases have different levels of strength. A strong alkali, something like sodium hydroxide, it completely breaks apart in water, ready to accept as many protons as it possibly can. But a weak alkali, like ammonium hydroxide, it's a little less aggressive. It only partially breaks apart. So, we've got our two main characters. On one side, the acid, our generous proton donor. On the other, the base, our eager proton acceptor. We've got a classic case of opposites attract, or maybe opposites react. So, what do you think happens when they finally meet? When these two totally opposite personalities come together in the same solution? Well, you know what's coming. We get a chemical reaction. And yeah, there's gonna be some sparks. Here it is, the script for their big scene. A strong acid, like hydrochloric acid, meets a strong base, like sodium hydroxide. The acid gives away its proton, the base grabs it, and in that moment, they transform into something completely new.
This whole process is called neutralization. The proton from the acid, that hydrogen ion, combines with a hydroxide ion from the base. And what do they make? H2O, plain old, perfectly neutral water. The two opposing forces literally cancel each other out. It's pretty amazing.
But wait, water isn't the only thing that's made here. This dramatic meeting gives birth to a whole new family of chemical characters, the salts.
Now, when I say salt, I'm not just talking about the stuff you sprinkle on your food. In chemistry, a salt is the compound that's left over after the acid's hydrogen ion has been replaced by a part of the base, usually a metallic ion. You could say it's the child of the acid and base union.
And this family of salts is surprisingly diverse. For example, if the acid's hydrogen is only partially replaced during that reaction, you get something called an acid salt, which, you guessed it, still has a bit of that acidic hydrogen left to give. But if it's completely replaced, you get a normal salt. It all just depends on which specific acid and base got together. And the variety, it doesn't even stop there. That one neutralization reaction can create this whole world of different salt compounds. We're talking double salts, mixed salts, complex salts, each one with its own unique properties and uses for everything from baking to bleaching. So get this. From a sour powerhouse and a bitter balancer, we get something totally new and neutral. It really makes you wonder, doesn't it? What other incredible combinations, what other powerful chemical stories are hiding all around us in plain sight, just waiting to be discovered